Here's a problem for you. Can you write the following fractions in base 6? So not in decimal expansions, but in expansions with the base 6 instead of 10. So the question is, can you write a third, a fourth, and a fifth in base 6? I'm going to do it next, so if you want to do it yourself, stop the video here. Let's start with a third. If I multiply a third by 6, I get 2. And then if I divide that equation by 6, what I get is that a third is equal to 2 divided by 6. This means in base 6 that the expansion in base 6 for a third is 0.2, because that number, that digit after the point, indicates how many sixths I need to express my number. So what I need is 2 divided by 6, so the expansion is 0.2 in base 6. Now, what about a fourth? If I multiply a fourth by 36, I get 9. And if I write 9 in base 6, I get 6 plus 3. Now divide through by 36 again, and what I get is that a fourth is equal to 1/6 plus 3 over 36. Therefore, the expansion in base 6 will be 0.13 for a fourth. Now, alternatively, I can do long division of 1 by 4 in base 6. So if I divide 1 by 4, 4 doesn't go into 1, so it's 0 point. And now to move the point in decimal, I would multiply 1 by 10 and then start dividing again by 4. But because we're in base 6, I have to multiply 1 by 6. So I get 6, and now 4 goes into 6 once, and I get that 6 minus 4 is 2. Now 4 doesn't go into 2, so I multiply again by 6, I get 12. 4 times 3 is 12, minus 12, I get a remainder of 0, and the division stops. So that means that the expansion in base 6 of 1 divided by 4 is 0.13. Now, let's see what happens with a fifth. A fifth times 6 is 6 divided by 5, which is 1 plus a fifth. If I multiply through by 6, I get a fifth is a sixth plus 1 over 30. That tells me that the very first digit of the expansion will be a 1. Now, 1 over 5 times 36 is 7 plus 1 over 5, and 7 in base 6 is 6 plus 1 over 5, multiply through by 36, and I get a sixth plus 1 over 36 plus more stuff. That tells me that the first two digits will be ones. But the fact that when I multiply a fifth by 6, I got a remainder of 1 over 5, and when I multiply a fifth by 36, I got a remainder of 1 over 5, and the fact that the digits that I started with are 1 and then more stuff, it leads me to believe that what's happening is that the expansion will be all ones, so 0.11111 infinitely many ones. So let's see if that expansion works. The expansion in base 6 with all ones corresponds to the sum of 1 over 6 plus 1 over 36 plus 1 over 6 cubed, etc., which is a geometric series, and I know how to add up geometric series. The sum will be 1 over 6 times 1 over 1 minus 1 over 6. And 1 minus 1 over 6 is 5 over 6, and if you simplify that expression, you get 1/5. So it does work. That tells me that the expansion in base 6 for 1 over 5 is 0.11111 infinitely many ones, so 0.1 periodic. Alternatively, I can do, like before, long division of 1 by 5 in base 6. 5 doesn't go into 1, so it's 0 point. I move the period, but to do that, I have to multiply by 6, so 1 times 6 is 6. That 5 goes into 6 by 1, so 5 times 1 is 5, 6 minus 5 is 1. Now I get the same remainder that I started from, so everything is going to repeat. Now I multiply 1 by 6, I get 6, I have to subtract 5, so 6 minus 5 is 1, and then multiply by 6, etc., 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 and that tells me that the expansion will be 0.111111 infinitely many ones. So the expansion of 1 over 5 is 0.1 periodic.